Hello everybody, our lesson today will talk about set of rational numbers. But first, we have sets of numbers like counting number. Counting number contain 1, 2, 3, 4 and so on. But if we subtract 1 from 1, 1 from minus 1 equals 0. Where is 0 in counting number? So we have a new set, it's natural number. Natural number contain what? Contain 0, 1, 2, 3 and so on. Very good. But in grade 6, we have 3 minus 4. 3 minus 4 equal negative 1. Where is negative 1 in natural number? We haven't got any negative numbers in natural number. So in grade 6, we have a new set. It's called integers. Integers and its symbol is capital Z. Integers contain 0, 1, 2, 3, 4 and so on, negative 1, negative 2, negative 3, negative 4 and so on. So 2 over 1 is an integer, but 3 over 4 it's a fraction and 8 over 9 is a fraction. Therefore, we have a new set, we called it the set of rational number and its symbol is capital Q. The definition of rational number: any number can be written as a ratio of two integers in the form a over b, but b not equal 0. In description method, we have x such that x equal a over b, and a belong to z and b to belong to z, but b not equal 0. An example: 12 over 2 equal 6. 12 over 2 is rational number and 6 is an integer. So 2 times 6 equal 12 and 12 times 1 equal 12. But in this example, 5 over 0. 5 over 0 equal what? We don't know. If we multiply 0 times x equal 0. 5 times 1 equal 1. So 0 times any number equals 0 but not equal 5. If we have 0 over 3 and 6 over 0, both of them are fractions, but 0 over 3 equal what? Equal 0. Very good. 6 over 0 equal undefined. So 0 over 3 is a rational number, but 6 over 0 not a rational number. We have a different form of rational numbers. Number 1, if we have a 3, we can write 3 as a form 3 over 1 or 6 over 2, 9 over 3 and so on. We can put 3 in the form a over b. Another example, like negative 5. Negative 5 we can write it as negative 5 over 1, negative 10 over 2 and so on, in the form a over b also. 57 we can write it as 57 over 1 and so on. That say all integers are rational number. We have another question. All rational number are integers? We will see. 10 over 3 is rational number, but 10 over 3 in the simplest form not equal a whole number. It's 3.3333 and so on. 57 over 5, it's a rational number, but 57 over 5 in the simplest form not equal whole number. It's 12.4. So not all rational numbers are integers. Example number 2. The 3.7 we need to write it in the form a over b. So 3.7 it will be 37 over 10. It's in the form a over b. 0.9 in the form a over b equal 9 over 10. So it's in the form a over b. 6.75 equal 675 over 100, and simplify it on your calculator. It will be in the form a over b also. So we can say all decimal numbers are rational numbers. Number 3, the percent. 30% equal 30 over 100. We can simplify it. It will be 3 over 10 and also in the form a over b. 9.7% equal 9.7 over 100 or 97 over 1000. So it will be in the form A over B. 0.78% equal 0.78 over 100, and simplify it. It will be 78 over 10,000. It will be in the form A over B. We can say all percentage are rational numbers. The form of rational numbers. We have fractional form like 1 over 2 and decimal form like 1 over 2 we convert it into a decimal number like 0.5, or it will be percentage form 1 over 2 we can convert it into percentage form by multiply by 100, it will be 50%. 1 over 2 and 1 over 3. 1 over 2 in the decimal form equals 0.5, but 1 over 3 equal 0.33333 and so on. So, what is the difference between them? We have 0.4, 0.72, 0.528. All of these have an end. It's called terminating decimal. But here, 0.4444 and so on, and 0.25, 25, 25 and so on, all of this it's repeated. So we call it recurring decimal. Recurring decimal like 1 over 3 on your calculator and press SD, it will be 0.33333. We can write it in another form like 0.3 and put a dot here like this. What's the meaning of dot? The dot above the digit means the digit is repeating. Another example, 2 over 11 equal 0.18, 18, 18, 18 and so on. We can write only 0.18 and put dot here and here because 18 is repeated. We have a relation between C and N and Z and Q. C contain 1, 2, 3, 4 and so on, and N contains 0, 1, 2, 3. We can say C included in N or C subset of N, and also N subset of Z and C subset of Z because Z contain the positive and negative integer and 0. In whole, we can say Q contain all of them, and C subset of N, and N subset of Z, and Z subset of Q, all of them subset of Q. Example number 1. Show why each of the following is a rational number. We can convert the mixed number into improper fraction. From grade 4, we can multiply 5 by 3, it will be 15, 15 plus 3 plus 2 equal 17, and write it in the form 17 over 5, it's a rational number. Negative 0.17, we can write it in the form negative 17 over 100, so it will be in the form A over B. Number C, 27% equal 27 over 100, and it's also a rational number. And important remarks, we have 0 over 8 equal 0. So, any fraction like A over B equals 0, we look at the numerator, and the numerator will be equal 0. X over 4 equals 0. Is it 4 equals 0? No. So, x equal 0. We look to the numerator. Another example, if we have x minus 2 over x minus 5 equals 0. So, x minus 5 equals 0 or x minus 2 equals 0. Very good. X minus 2, it will be equal 0, and solve the equation. 2, it will be plus in the other side, plus here, and x equal in final, it will be plus, so x equal 2. Another example, 5 over 0, we said and defined, very good. So 5 over 0 not belong to Q. So 5 over 0 is not a rational number. If we have a fraction like 6 over x not belong to Q, we can say x not equal 0. Another example, if we have 8 over x minus 10, so, and this fraction not belong to Q, we can say x minus 10 equals 0 to get the 0 of the denominator, x equal 10. Another fraction, if we have x minus 5 over x plus 3, we said it doesn't belong to Q and we look to the denominator. So the denominator is x plus 3, take x plus 3 here and equal 0, solve the equation, x equal negative 3. Example number 2. If x is an integer, write the required condition to make each of the following a rational number. 3 over 2x, to be a rational number, the denominator must be not equal 0. So 2x not equal 0, take 2 from here to here by division, and x will not equal 0. Another example, if we have 7 over x minus 3, to be a rational number, we take the denominator and write not equal 0, take 3 from here to here by the inverse sign, x will be equal not equal 3. Example number 3, write each of the following numbers in the form of percentage. To convert any fraction or any number into the percent form, we multiply up and down by 100 or make the denominator by 100. So we multiply up and down by 100, it will be 45 over 100, it means 45%. 5 over 16, to convert it into percent, we multiply up and down by 100 like this, it will be 31.25 over 100, it means 31.25%. Example number 4, to write each of the following numbers in the form of terminating decimal. 2 over 5, we can convert it on calculator or by steps, like make the denominator by 10 or 100 or 1000. We can multiply up and down by 2 to convert 5 into 10. It will be 4 over 10, so it will be 0.4. The absolute term, or absolute value negative 3 over 8, absolute value negative 3 over 8 multiplying by 125 up and down to make the denominator 1000. So 3 over 5 over 8, it will be 375 over 1000, it will be 0.375. Thank you and goodbye.